Okay, today we are learning the law of cosines, the formula we are about to derive. You will have to have this memorized for our test next week. Okay, so we're going to start with deriving the formula for the law of cosines. And we're going to start by looking at the left right triangle. So looking at this left right triangle, we are going to use the Pythagorean theorem on this right triangle. And what is the Pythagorean theorem? A squared plus b squared equals c squared. So a and b are the two legs. So the first or bottom leg is a minus x. So a minus x needs to be squared. And the other leg is h, needs to be squared. And that's equal to the hypotenuse squared. And what is the hypotenuse for that right triangle? C. So this would be c squared. Now remember our shortcut when you square a binomial? If I have a plus b squared, you take the first term and square it, which would be a squared. You multiply these and double it, so that would give us 2ab. And you square the last term, so that would be b squared. So let's go ahead and square that binomial using our shortcut. So if I square the first term, what does that give me? A squared. If I multiply these and double it, what does that give me? Negative 2ax. And if I square that last term, what does it give me? Plus x squared. So now we just square the binomial. Behind that we have plus h squared equals c squared. Now looking at this part right here that I'm grouping in parentheses, x squared plus h squared. I would like to find something I could replace x squared plus h squared with. From this diagram over here. What could I replace x squared plus h squared with? Let's see, if I had x squared plus h squared, that would be equal to b squared. So instead of x squared plus h squared, let's replace that with b squared. So that would be a squared minus 2ax. Instead of x squared plus h squared, I'm going to put b squared equals c squared. Now the next thing I want to do is just use the commutative property of addition. I want to get the a squared and b squared out front so it looks better, like standard form. A squared plus b squared minus 2ax equals c squared. We're almost there. Hit the pause button for a second. So we're pausing over here. Now let's come back over here and let's find the cosine of angle C. Remember, if you're using SOHCAHTOA, you have to be looking at a right triangle. So the right triangle that has angle C in it is this right triangle I'm highlighting in black. So how do you find cosine? Adjacent over hypotenuse. So what side is adjacent to angle C? X. And what's the hypotenuse for that right triangle? B. Now I want you to take this equation and solve it for x. So if x is being divided by b, the opposite would be multiply both sides by b. So that gives me b times the cosine of c is equal to x. Now I'm going to unpause myself. Now we're going to go back to that original equation we were working with, but instead of x, I'm going to substitute in what x is equal to, which is b cosine c. So that gives us a squared, or let me bring this down a little bit so it's not confusing anything. So this would be a squared plus b squared minus 2a. Now instead of x, I need to substitute in what we solved over here, which is B times cosine of angle C, is equal to C squared. And we just derived the law of cosine. So there are two versions for the law of cosine. Now most textbooks have the C squared written first. So let me write it the way that you'll see it in most textbooks. So C squared equals A squared plus B squared minus 2AB times the cosine of angle C. That's the main version. Now there's two alternative versions. You could have A squared equals B squared plus C squared minus 2 times B times C times cosine of angle A. And the third version is B squared equals A squared plus C squared minus 2AC cosine of angle B. And all three of these are called the law of cosine. What did I write right there below where it says law of cosine? Memorize. So you have to have this formula memorized, and there's three versions. Now really you don't have to memorize all three versions. You really just have to memorize the general format. So let me point out some things about the general formatting to kind of help you in your memorization process. So the first thing I want to point out is notice over here we have C squared by itself. And what angle do we have over here with the cosine? C. Over here I have A squared by itself. What angle do I have with the cosine? Angle A. Over here I have B squared by itself. What angle do I have over here with the cosine? B. So those are always going to match every single time. Now whatever variable is by itself over here, you're going to use the other two sides of the triangle. So if you have C over here, what are the other two sides? A and B, A and B. If I have A over here by itself, what are the other two sides of the triangle? C and C, C and C. If I have B by itself, what are the other two sides of the triangle? A and C, A and C. So really you just have to memorize the general format, and if you know those two things, that if you have C squared over here by itself, you have to have angle C, and the other two sides are A and B, then you'll know the three formats. So you really just have to know the general format. Okay, next, below that, we have a text box with some important information for us. So that first bullet tells us that the law of cosines and the law of sines can be used to solve non-right triangles. So that means you have a triangle that does not have a 90-degree angle in it. And Friday, when we talked about the law of cosine, we called these types of triangles obliques. So when they're talking about a non-right triangle, they're talking about the oblique triangles we saw on Friday. So it's a triangle that does not have a 90-degree angle in it. Second bullet says that the law of sines cannot distinguish between acute and obtuse angles because both first quadrant and second quadrant angles have positive ratios for sine. Now we'll be talking about this in our next unit next week, which is Unit 5, where we're talking about the unit circle. So if you don't understand all of this, that's perfectly fine. But they're talking about if you have an acute angle in quadrant 1. So here's my angle in quadrant 1. Notice it's less than 90 degrees. Now if I have an obtuse angle that terminates in quadrant 2, Notice that angle in green is obtuse. Now, when we're talking about sine and cosine in quadrants 1 and 2, we'll learn this later. We use S for sine, C for cosine. In quadrants 1 and 2, the sine is both positive. So what that tells us is that if the sine value is positive, the law of sines will not be able to determine if our angle should be acute or obtuse. Now, the third bullet. It says that the law of cosines can distinguish between an acute angle and an obtuse angle. So here I still have my acute angle in red and my obtuse angle in green. And in quadrant 1, cosine is positive, but in quadrant 2, cosine is negative. So the law of cosines can be used to distinguish between an acute angle and an obtuse angle. So when we're trying to solve triangles today, if that angle could be obtuse, you have to use the law of cosines, because the law of cosines can tell if it's acute or obtuse. Now, if it's not going to be obtuse, you can use the law of sines. It will be quicker and faster. And the last bullet, it says that when solving for the angle, if there is any possibility that the angle you are solving for is obtuse, do not use the law of sines. So that's a whole important thing for that entire text box. And let me highlight it. So if there is any possibility that the angle you are solving for is obtuse, what does obtuse mean? More than 90 degrees. So if it's a possibility that that angle is more than 90 degrees, what does it say? Do not use the law of sines. You have to use the law of cosine. So if you're solving for an angle and it could be more than 90 degrees, you have to use the law of sines. Not the law of sines, the law of cosine. You have to use the law of cosine so that angle could be more than 90 degrees. If you use the law of sines, it might give you the wrong answer. It might give you an obtuse angle when it actually should be acute. So if the angle you're solving for is more than 90 degrees, do not use the law of sines. You must use law of cosine. And the last important thing is to remember that the largest angle in a triangle is always opposite of the longest side in that triangle. So remember that rule from geometry. The largest side is going to be opposite of the largest angle. Now that's the most important thing that I highlighted in blue. If your angle could be obtuse, do not use law of sines. What do you have to use? Law of cosine. So let's get started with the law of cosine. Okay, so it says solve a triangle. So remember, when you're solving a triangle, you need all three sides and all three angles. And it says round sides to the 10th and angles to match or as stated. So when it talks about matching, that means if they use degrees a minute, you have to use degrees a minute as well. But over here, what does it say right here? Whole degree. So we're rounding our angles to the nearest degree according to the instructions. So we need angle A, angle B, angle C, and we'll need side A, side B, and side C. And go ahead and draw yourself a diagram. Side A is 9, side B is 10, side C is 13. And then fill in your given information. Now on Friday we were able to use the law of sines because we had an angle and a side pair. But do we have an angle and a side pair? No. So we will have to use the law of cosine. So which one do we want to solve for first? Angle A, B, or C? B? Okay. So if I want to solve for angle B, I have to use the formula that has the B squared. So this means B squared equals What are the other two sides of the triangle? A and C. So this needs to be A squared plus C squared minus 2AC times the cosine. Now this angle has to match what's by itself over here. So if this is a B squared, this needs to be cosine of angle B. So there's my formula that I have to memorize. Now go ahead and substitute in what we know. So in that equation, instead of B, it needs to be a 10. Instead of A, it needs to be a 9. Instead of a C, it needs to be 13 minus 2 times 9 times 13 times the cosine of angle B. And angle B is what we're solving for. Now, solve that equation. We want to get the cosine by itself. What is 10 squared? 100. Go ahead and put this in the calculator. 9 squared plus 13 squared. What's 81 plus 169? 250. 250? And go ahead and multiply these three. What's negative 2 times 9 times 13? Negative 234. Negative 234? Mm-hmm. Cosine of angle B. Okay, now, we want to get that cosine by itself. So what would be our next step to get the cosine by itself? Subtract 250 to both sides. 100 minus 250 would be negative 150 equals negative 234. Cosine of angle B. Divide both sides by negative 234. Negative divided by negative becomes positive 150 over 234. Now this fraction does simplify, but you're about to put it in a calculator anyway, so it doesn't matter if you simplify that or not. But notice this is an arc cosine value. So this is an arc cosine value. How would I need to enter that into the calculator? You do second cosine, which would be cosine to the negative 1, so inverse of cosine. And then inside the parentheses, you need to do 150 divided by 234. And how did it say to round these angles? Nearest whole degree. So what is angle B to the nearest whole degree? Well, first of all, our answers need to be in degrees. So make sure your mode is set to degree mode. And what is angle B to the nearest degree? 50 degrees. 50 degrees? We agree? Okay, so angle B is 50 degrees. Now, for angle C, I have to ask myself, is it possible for angle C to be obtuse? What does it mean to be obtuse? More than 90? Would it be possible for angle C to be more than 90 degrees? Yes. Yeah, that could be legitimate, right? So if it's possible to have another angle that's more than 90 degrees, you have to use the law of cosine. You have to use law of cosine. That was that fourth bullet. So we already did the one with B squared. Which one do we want to do now? C squared, so that would be C squared equals, what are the other two sides? A squared plus B squared minus 2 AB cosine of angle C. Then fill in what we know. Side C is 13. Side A is 9. B is 10. Minus 2 times 9 times 10 times the cosine of angle C. What is 13 squared? 169. So this would be 169 equals, go ahead and add these together. What's 81 plus 100? 181. 181. Go ahead and multiply these three. What's negative 2 times 9 times 10?
Negative 180.
Negative 180 times the cosine of angle C. Now we want to get the cosine by itself, so what should we do next? Subtract 181 to both sides. What is 169 minus 181?
Negative 12.
Negative 12 equals negative 180 times the cosine of angle C. Divide both sides by negative 180. And this is another arc cosine value. And a negative divided by negative becomes positive. So make sure in the calculator you do second cosine. And inside the parentheses you need 12 divided by 180. And what is angle C to the nearest whole degree? 86 degrees. So was that one actually obtuse? No, that one was actually acute. So angle C is 86 degrees. Do I have to do all cosines again?
No.
No, we should know that all three angles add up to what? 180. So what's 50 degrees plus 186 degrees? So what's 180 degrees minus 136 degrees? 44 degrees. So that last angle, angle A, would have to be 44 degrees. So again, if the angle you are solving for could be obtuse, which means it's more than 90 degrees, you have to use law of cosine. That way it will figure out if that angle is actually acute or obtuse. Okay, next one, number 2. Again, draw yourself a diagram, and notice angle A is in degrees and minutes, so all of our degrees for angles need to be in degrees and minutes. Go ahead and fill in the given information. So angle A is 39 degrees, 24 minutes. Side B is 12. Side C is 14. Now for law of sines, we had to have an angle and side pair. Do we have an angle and side pair? No. So we cannot use law of sines. We have to use law of cosine. So we have several different ones. We have the one with A squared, the one with B squared, the one with C squared. Now notice I'm given angle what? Angle A. So I need to use the formula that has cosine of angle A. So which formula do I use? The one with C squared, B squared, or A squared? A squared. So the formula is going to be A squared equals, what are the other two sides? B squared plus C squared minus 2BC cosine of angle A. Then fill in what we know. We're solving for side A. So we'll keep the A squared. What do I put for B?
4.
So this would be 12 squared. Plus, what do I put for C? 14 squared minus 2. What do I put for B and C? 12 and 14. Cosine. And A is 39 degrees, 24 minutes. Now, let's not try to do a whole bunch of unnecessary work. We're solving for A. What's happening to A? It's being squared. So what's the inverse of squaring? Square root. So square root the left side, square root everything on the right side. And let the calculator do it for you. So the square root of a squared is a, and we are rounding side to the nearest tenth. Now notice your angle is in degrees, minutes, and seconds. Do you remember how to do that in the calculator? If you have a degree, you need to do second at number 1. And for the minute, you need to do second at number 2. What is side A to the nearest 10?
9.0.
9.0. We'll just put 9. Now I have an angle and side pair, so technically I could use the law of sines as long as angle B or angle C cannot be obtuse. But is it possible for angle B or C to be obtuse? Could they be more than 90? Yes, so I can't use law of sines. What do I have to use if it could be obtuse? I have to do log cosine again. So I already did the one with a squared. Which one do we want to do next? B squared or C squared? B squared. So this is B. B squared equals, where's the other two sides? A squared plus C squared minus 2AC times cosine of angle B. Then fill in what we know. Side B is 12, so this would be 12 squared equals A. We just solved for A, and A is 9. C is 14 minus 2 times 9 times 14 times the cosine of angle B. We will have to use the rounded here. We have to. No way around it. So if you have to, you have to. We try to avoid it, but we can't avoid it here. Okay, so 12 squared is 144. And the calculator was 9 squared plus 14 squared. 177? 277. And multiply these three with negative 2 times 9 times 14. Negative 252 times cosine of angle B. How do we get cosine by itself? Subtract 277 to both sides. What is 144 minus 277? Negative 133 equals negative 252 cosine of angle B. Divide both sides by negative 252. And the cosine is by itself. So this is an arc cosine value. So make sure you do second cosine. And negative over a negative becomes positive. So in the calculator, second cosine of 133 divided by 252. And we're we're not rounding. Tell me what this first answer is. 58.1. But how do we have to have our answers? Degrees in minutes, we have to match what they gave us. So after you have this answer, then you have to convert this to degrees, minutes, and seconds. And on the calculator, that was second at number 4. So this would be 58 degrees, and how many minutes? 8.
When you round up, because you said it has 40 seconds after.
What was it? It was 58, what did your calculator say, 58 degrees, what was next?
8 minutes and 40.449.
8 minutes and 40 point what?
449.
449 seconds. So when, yes, we will have to round. So if your second is 30 or more, it rounds up. So instead of 8 minutes, it needs to round up to 9 minutes. So 58 degrees, 9 minutes. So round to the nearest minute. So 58 degrees, 9 minutes. So if your second is 30 or more, round up. So 58 degrees, 9 minutes, and that was for angle B. So 58 degrees, 9 minutes. And once you have two angles, you can find the third angle. So you can do this in the calculator, 180 degrees minus 39 degrees, 24 minutes, minus 58 degrees, 9 minutes. And what do you get? Degrees. I don't think it's 28 minutes. Okay, what did we get? It was 27 minutes, and that, if you add all three of these up, then that adds up to 60 minutes, which is equal to 1 degree. And what were the degrees? 82 degrees, 27 minutes. Do you agree? Okay, next problem. Number 3. Here we go. Draw your diagram. Here's A, here's B, here's C. Angle B is 35 degrees. Side A is 5. Side C is 6. Fill in what we're given. Now, to use law of sines, you have to have an angle and side pair. Do we have an angle and side pair here? No, so we have to use the law of cosine. So to figure out, do I use the one with a squared, b squared, or c squared, look at our triangle, and what angle do we have? Angle B. So that means my formula has to have cosine of B in it. So which of those formulas would I have to use? The a squared, b squared, or c squared? B squared. So the formula we have to use would be b squared equals a squared plus c squared minus 2ac cosine of angle B. This time we're solving for side B, so keep your b squared. And what do we put for A? So that would be 5 squared plus, what do we put for C? 6 squared minus 2 times 5 times 6 times cosine of B is 35 degrees. Solving for B, if B is being squared, what's the inverse of squaring? Square root. So square root the left side, square root the right side. And side length, we're rounding to the nearest tenth. And what is side B to the nearest tenth?
3.4.
3.4? Looking at angle A and C, would it be possible for A or C to be obtuse? Yes. So if it's possible to have an obtuse angle, do I use law of sines or law of cosine? All cosine. So do you want to do the a squared or c squared?
A squared.
A squared, so that would be a squared equals b squared plus c squared minus 2 bc cosine of which angle? A. What do I put for A? 5 squared equals B is, yeah, we just got that answer, 3.4. And C is 6. And now we have to get that cosine by itself. So what is 5 squared?
25.
25. And what's 3.4 squared plus 6 squared? 47.56. And multiply these 3 with negative 2 times 3.4 times 6. Negative what?
40.
Negative 40.8. Cosine of angle A. What's next? Subtract 47.56 to both sides. And what do we get? 25 minus 47.56. Negative 22.56 equals negative 40.8 times the cosine of angle A. Divide both sides by negative 40.8. And cosine is by itself. Make sure in the calculator you do second cosine of that fraction. And we're rounding to the nearest whole degree, right? Yes. If we match, they round to the nearest whole degree. And what would angle A be to the nearest whole degree? 56 degrees. So angle A is 56 degrees. And you add these two with 56 plus 35. What is it? And 180 degrees, not 100, yeah, 180 degrees minus, what does he add up to? 91 degrees. What's 180 degrees minus 91 degrees? 89 degrees. So angle C is 89 degrees. Okay, now we have some more problems. Yes, I know, it's right. Number 4 says the parallelogram has sides of 55 centimeters and 71 centimeters. Find the length of each diagonal to the nearest 10th if the larger angle measures 106 degrees. So we have ourselves a parallelogram. Go ahead and draw yourself a little diagram. There's my parallelogram. One side is 55 centimeters. The other side is 71 centimeters. The larger angle is 106 degrees. Now remember, when you're talking about triangles, the larger degree is going to be opposite of the larger side. So here my larger side is 71 degrees, so the angle opposite needs to be 106 degrees. And if this is a parallelogram, these two angles add up to what? 180 degrees. So what's 180 degrees minus 106 degrees?
74.
74 degrees. So that top angle, the smaller angle, is 74 degrees. Now they asked us to find the length of each diagonal. So diagonal number 1. We need to find the length of that line in green. Now, I'm going to go ahead and pull that triangle out. That way it's easier. So the top side is 71, right side is 55 degrees. This angle, top right, is 74 degrees. So I just pulled out this triangle right here. This one right here is what I pulled out. Now, for our purposes, I'm going to call this triangle A, B, C. So what we're actually needing to solve for is side B. Side B is that diagonal. So to solve for side B, would I have to use the formula as A squared, B squared, or C squared by itself? Yeah, if I have angle B, I have to use the B squared formula. So B squared equals A squared plus C squared minus 2AC times the cosine of angle B. Fill in what we know. We're solving for side B, so keep the B squared. What do we put for A? 55, so this would be 55 squared. Plus, what do I put for C? 71 squared minus 2 times 55 times 71 times cosine, and angle B is 74 degrees. Solving for B, if B is being squared, the inverse of squaring would be square root both sides. Square root the left side, square root the right side. And what would that side or diagonal be to the nearest tenth?
76.9.
76.9, and we need units, so we need centimeters. And that's for diagonal number 1. Now we need that second diagonal. I'm going to mark that second diagonal in red. And I'm going to pull that triangle out. So now looking at this triangle in pink. The bottom angle is 106. That bottom side is 71. The right side is 55. So that triangle in pink, this bottom angle is 106 degrees. Bottom side is 71. Right side is 55. And I'm going to call this triangle A, B, C. I want you to solve for that diagonal, which is side C. If I have angle C, I have to use the formula with the C squared. So C squared equals A squared plus B squared minus 2AB times the cosine of angle C. We're solving for C. A is 55. B is 71. Angle C is 106 degrees. squared, the inverse would be square root it. And what is side C, the second diagonal to the nearest tenth?
101.1.
101.1 centimeter for diagonal number 2. If they ask you for the diagonals, make sure you have both included with your answer. Yes?
Never mind, no. Okay. I mean, you can use the other triangle as well, right? The,
Yes, you can use the other triangle. Yeah.
I just mentioned it.
Okay, last one. Number 5, it says A is 6, B is 12, C is 15. Find the length of the median to the longest side. Draw yourself a diagram. Here's angle A, angle B, angle C. Side A is 6, side B is 12, side C is 15. We want to find the length of the median. Whew. Geometry, what's median? It goes from the angle to the opposite side, and it cuts the opposite side in half. So the median to the longest side, well, which one of those is the longest side, A, B, or C? C. So it's side C that needs to be cut in half. And that median needs to go from the middle of side C to angle C. So there's my median. So if side C is 15, what's half of 15? 7.5. So this piece is 7.5. This piece is 7.5. We need to figure out what is this length here. Well, if I look at just the bottom triangle, do I have enough information to find side A? No, in order to find side A, what angle would I have to know? I would have to know angle A. If I want side A, I would have to know angle A. So do I know what angle A is? No. So that's the first thing we need to do. We need to find the measure for angle A. So using that outermost triangle, using the big triangle, ABC, using that outer triangle, I can use the law of sine, not the law of sine, the law of cosine, to find the measure for angle A. So if I'm looking for angle A, do I have to use the formula with A squared, B squared, or C squared?
A squared.
A squared, so this needs to be A squared. Equals B squared plus C squared minus 2BC times the cosine of angle A. So looking at the big triangle, what is side A? 6 is right, so 6 squared equals. What is side B? 12 squared. And what is C squared? 15 squared minus 2 times 12 times 15 times the cosine of angle A. What is 6 squared? 36. What's 12 squared plus 15 squared? 369. What's negative 2 times 12 times 15? Negative 360. Times the cosine of angle A. What would be the next step to get cosine by itself? Subtract 369 to both sides. What is 36 minus 369? Negative 333 equals negative 360 times the cosine of angle A. Divide both sides by negative 360. And that's an arc cosine value, so make sure you do second cosine of 333 divided by 360. And what is angle A to the nearest whole degree? 22 degrees. So back up to my original diagram, now we know that this is 22 degrees. And now, how can I find this side A on that triangle in pink?
Did you use sine?
Oh, can we do all sides there? Do we have an angle inside here? On the little triangle, on the pink triangle? No, so we can't use all signs, so we have to use cosine. So if I want side A, do I have to use A squared, B squared, C squared? A squared. Don't do that up here. Here we go again, A squared equals C squared plus C squared minus 2BC cosine of angle A. Luckily, we're solving for A squared, so we can just put this one all on the calculator. We really don't have to solve anything, just square root everything. Okay, so B, what do I put for B? 12 squared plus, what do I put for C on the pink triangle? So 7.5 squared minus 2 times 12 times 7.5 times the cosine, and we now know that angle A is how many degrees? 22 degrees. And if A is being squared, the inverse would be square root. And what is the length of that median to the nearest tenth?
5.8.
5.8, and we don't have units, so it's just 5.8.